नमस्ते दोस्तों, वेलकम टू सारास एनालिटिक्स अरीना, जहां हम एनालिटिक्स और डाटाबेसेस के कॉन्सेप्ट्स सिंपल लैंग्वेज में समझते हैं। आज के इस वीडियो में हम बात करेंगे एसक्यूएल के इम्पॉर्टेंट इंटरव्यू क्वेश्चंस और उनके आंसर्स के बारे में। ये क्वेश्चंस आपको किसी भी एसक्यूएल डेवलपर, डेटा एनालिस्ट या बिजनेस इंटेलिजेंस रोल के इंटरव्यू में मिल सकते हैं। तो चलिए बिना टाइम वेस्ट किए शुरू करते हैं। So let's start making you interview ready. So guys, what is SQL? SQL, Structured Query Language, is a standard language used to interact with relational databases. It allows users to store, retrieve, manipulate, and manage data efficiently. SQL is widely used in data analysis, web applications, and enterprise systems to handle structured data. SQL was first developed in the 1970s by IBM researchers and became an ANSI standard in 1986. It is essential for working with relational database management systems (RDBMS) such as MySQL, PostgreSQL, SQL Server, and Oracle. Now, what are the different types of SQL commands? SQL commands are categorized into 5 major types, each serving a specific purpose in database management. First is DDL, Data Definition Language. DDL commands are used to define and manage the structure of the database objects such as tables, indexes, and views. It includes commands like create, alter, drop, and truncate. Second is DML, Data Manipulation Language. DML commands are used to manipulate the data stored in tables. It includes commands like insert, update, and delete. Third is DQL, Data Query Language. DQL is used to retrieve data from databases using select. It includes commands like select. Fourth is DCL, Data Control Language. DCL commands control user access and privileges in a database. It includes commands like grant and revoke. Fifth is TCL, Transaction Control Language. TCL commands manage transactions in a database to ensure data integrity. It includes commands like commit, rollback, save point. What is the difference between delete, truncate, and drop? The delete, truncate, and drop commands in SQL are used to remove data, but they work differently. First is delete command. The delete command removes specific records from a table based on a condition. It allows selective deletion and can be rolled back if used within a transaction, making it safer when you need to remove some but not all records. However, delete is slower because it logs each deleted row. Second is truncate. Truncate removes all rows from a table but retains the table structure. It is much faster than delete since it does not log individual row deletions, but it cannot be rolled back, making it a permanent operation. Additionally, truncate resets identity columns, auto-increment values. Third is drop command. Drop completely removes the table, including its structure, from the database. This command is the most destructive and fastest among the three because it not only deletes the data but also eliminates the table itself. Unlike delete and truncate, drop cannot be undone, so it should be used with caution when a table is no longer needed. In summary, use delete when you need to remove specific records with the option to roll back, truncate when you need to clear all data quickly while keeping the table, and drop when you want to permanently remove the table from the database. Now, what is a primary key? A primary key in SQL is a column or a set of columns that uniquely identifies each record in a table. It ensures that no two rows have the same value in the primary key column, maintaining data integrity and uniqueness. A primary key cannot have null values and must always contain unique values. A primary key can consist of a single column or multiple columns, composite key. What is the difference between primary key and unique key? The primary key and unique key are both used to enforce uniqueness in a table, but they have key differences in functionality and constraints. Primary key. A primary key is a column or a set of columns that uniquely identifies each record in a table. It cannot contain null values and ensures data integrity by preventing duplicate values. Each table can have only one primary key, and it automatically creates a clustered index for faster retrieval. Unique key. Unique key also enforces uniqueness, ensuring that no duplicate values exist in a column. However, unlike a primary key, a unique key can contain null values, but only one null per unique column. A table can have multiple unique keys, and they create a non-clustered index by default. What is the difference between where and having? The where and having clauses in SQL are both used to filter records, but they serve different purposes and work at different stages of query execution. The where clause is used to filter rows before any grouping or aggregation, group by, happens. It is used with individual records and applies conditions on columns directly. Where cannot be used with aggregate functions like sum, average, or count. The having clause, on the other hand, is used to filter records after grouping, group by. It is specifically designed to work with aggregate functions and filters groups rather than individual rows. What is an index in SQL? An index in SQL is a database object that improves the speed and efficiency of retrieving data from a table. It works like an index in a book, helping the database find rows quickly without scanning the entire table. Indexes are mainly used on large datasets to optimize query performance. There are different types of indexes in SQL. First is primary index. It automatically created when a primary key is defined. It ensures unique and fast access to each record. Second is unique index. It ensures that all values in a column are unique, similar to a unique key constraint. Third is clustered index. It stores table rows in sorted order based on the indexed column. Each table can have only one clustered index. Fourth is non-clustered index. Creates a separate structure from the table and stores pointers to the actual rows. A table can have multiple non-clustered indexes. Fifth, composite index. It is an index on multiple columns to optimize queries that filter based on those columns. Sixth is full text index. It is used for searching text-based data efficiently. What are joins in SQL? Explain types of joins. A join in SQL is used to combine data from multiple tables based on a related column between them. Joins help retrieve meaningful data by linking rows from different tables using a common key, usually a primary key and foreign key relationship. There are different types of joins in SQL. First is inner join, which is also called as default join. Returns only matching records from both tables where the join condition is met. Second is left join, also known as left outer join. Returns all records from the left table and matching records from the right table. If there is no match, null is returned for the right table. Third is right join, also known as right outer join. Returns all records from the right table and matching records from the left table. If there is no match, null is returned for the left table. Fourth is full join, full outer join. Returns all records from both tables. If there is no match, null is returned for missing data. Next is cross join. Returns every possible combination of rows from both tables, Cartesian product. Sixth is self join. A table joins with itself, useful when comparing records within the same table. What is normalization? Normalization is the process of organizing data in a database to reduce redundancy, duplicate data, and improve data integrity. It helps in designing efficient database structures by breaking larger tables into smaller, related tables and establishing relationships between them using keys, primary and foreign keys. The main goals of normalization are: first is eliminate data redundancy, avoid storing the same data multiple times. Second is ensure data integrity, prevent data inconsistencies. Third is improve query performance, make queries more efficient by reducing table size. What is denormalization? Denormalization is the process of combining tables to improve read performance by reducing the need for complex joins. It is the opposite of normalization. Instead of splitting data into multiple tables, redundant data is added to improve query speed, especially for large-scale databases used in reporting and analytics. While normalization eliminates redundancy and improves data integrity, it can make queries slower because they require multiple joins. Denormalization reduces the number of joins by storing frequently accessed data together, making queries faster but increasing data redundancy. Now, uses of denormalization. First is faster query performance, reduces the need for expensive joins. Second is simplifies complex queries, easier to fetch data from a single table. Third is improves reporting AMP analytics, helps in data warehousing scenarios. What is a foreign key? A foreign key is a column or a set of columns in a table that creates a relationship between two tables. It enforces referential integrity, ensuring that the value in the foreign key column must exist in the reference table. In simple terms, it is used to link one table to another by referencing the primary key of another table. Key points about foreign key. First is establishes relationships, connects data across multiple tables. Second is ensures data integrity, prevents invalid or orphaned records. Third is prevents unwanted deletions, restricts or cascades deletions based on constraints. What is the difference between union and union all? Both union and union all are used to combine the results of two or more select queries. However, there is a key difference in how they handle duplicate records. So union, it removes duplicates. The union operator merges the results of multiple queries and automatically removes duplicate rows. Hence, use union when you need only distinct or unique values. The performance is slightly slower because it checks for duplicates. Now, union all, it keeps duplicates. The union all operator also combines results but does not remove duplicates. Hence, use union all when you need all records, including duplicates, and want better performance. The performance is faster than union because it doesn't check for duplicates. What is a subquery? A subquery is a query inside another query. It is also called a nested query or inner query because it runs first to provide results for the outer query. Subqueries are enclosed within parentheses and can be used in select, insert, update, or delete statements. Now, types of subqueries in SQL. First is single row subquery, returns a single value, and used with comparison operators like equal to, greater than, and smaller than, etc. Second is multi-row subquery, returns multiple rows or values and is used with in, any, or all. Third is correlated subquery, executes once for each row. A correlated subquery depends on the outer query, executing once for each row. What is a stored procedure? A stored procedure is a precompiled SQL code that is saved in the database and can be executed multiple times. Instead of writing the same query repeatedly, we can create a stored procedure and call it whenever needed. Only the procedure call is sent instead of full SQL queries, which reduces network traffic and improves performance. It enhances security by preventing SQL injection attacks and ensures code reusability. A stored procedure can return multiple values or none and can modify data using insert, update, and delete statements. It can accept parameters for dynamic execution, making it more flexible. A stored procedure cannot be used inside a select statement. It is particularly useful for batch processing, handling complex logic, and reducing query repetition in large-scale applications. What are triggers in SQL? A trigger in SQL is a special type of stored procedure that automatically executes when a specific event occurs in a database. Triggers are used to enforce business rules, maintain data integrity, and automate database tasks. They are activated by insert, update, or delete operations on a table. A trigger is associated with a particular table and executes either before or after the specified event. There are two main types of triggers: row-level triggers, which execute once for each affected row, and statement-level triggers, which execute once per SQL statement. Example: if a delete trigger is set on an employee's table, it can automatically insert a record into an audit log table to track deleted employees. Triggers help in automating tasks such as maintaining logs, restricting unwanted changes, and enforcing referential integrity without manual intervention. However, excessive use of triggers can lead to performance issues because they execute automatically and may slow down database transactions. What is a view in SQL? A view in SQL is a virtual table that is created based on the result of a select query. It does not store data physically but dynamically fetches data from the underlying tables whenever accessed. Views help in simplifying complex queries, improving security by restricting direct access to tables, and ensuring data abstraction. A view can be created using the create view statement and can include one or multiple tables. Views can be updated if they are based on a single table and follow certain conditions, but complex views with multiple joins or aggregations may not allow modifications. There are two main types of views: simple views, which retrieve data from a single table, and complex views, which involve multiple tables, joins, and aggregations. Since views do not store data separately, querying a view might be slightly slower than querying a table, especially for large datasets. What is the difference between char and varchar? Char and varchar are both data types used to store character strings in SQL, but they differ in how they store and manage data. Char is a fixed-length data type, meaning it always reserves the specified number of bytes, regardless of the actual data stored. If the defined length is 10, but the stored value is SQL, it still occupies 10 bytes with extra spaces padded. Char is best for storing fixed-length data like PIN codes, country codes, and fixed-length identifiers. Varchar is a variable-length data type, meaning it only uses the required space for the stored data plus an additional 1 or 2 bytes for length information. If the defined length is 10 and the stored value is SQL, it only occupies 3 bytes plus 1 byte for length storage. Varchar is more efficient for varying length data as it saves space. Varchar is preferable for storing variable-length text like names, addresses, and descriptions. If frequent updates occur, char may be preferable since its fixed size avoids fragmentation, whereas varchar can cause performance issues when modified frequently due to dynamic storage allocation. What is a CTE, Common Table Expression? CTE means Common Table Expression is a temporary result set that is defined within a SQL query and can be used multiple times within the same query. It is created using the with keyword followed by a subquery and exists only for the duration of the query execution. CTEs improve code readability, simplify complex queries, and allow better organization of SQL logic, especially when working with recursive queries or multiple joins. There are two types of CTEs: non-recursive CTEs, which work like temporary views and retrieve static data, and recursive CTEs, which refer to themselves to process hierarchical or iterative data. Unlike subqueries, CTEs can be referenced multiple times in the same query, making them more efficient for complex calculations and hierarchical queries. Since CTEs exist only during the execution of a query, they do not consume permanent storage like tables or views. CTEs are particularly useful in scenarios like breaking down complex queries, simplifying recursive operations, and improving query maintainability in large SQL scripts. What is a self-join? A self-join is a type of SQL join where a table is joined with itself. It is used when we need to compare rows within the same table. Since the same table is used twice in the query, aliases must be assigned to differentiate between the instances of the table. Self-join is commonly used to find hierarchical relationships such as employee-manager relationships, product dependencies, or friend connections in a social network. A self-join can be performed using inner join, left join, or right join, depending on whether we want to include employees who do not have a manager. Unlike traditional joins that link to different tables, a self-join helps in querying hierarchical or related data within the same table. It is useful in parent-child relationships, bill of materials processing, and social network analysis where relationships exist within a single dataset. What is the difference between rank, dense_rank, and row_number? Rank, dense_rank, and row_number are window functions used to assign a unique ranking to rows based on a specific column's order. They are commonly used in scenarios like finding top salaries, ranking students, or handling duplicate values in ordered data. Rank assigns a rank to each row but skips the next rank if there is a tie, duplicate values. The ranking gaps when duplicate values exist. If two people tie for second place, the next person gets fourth place because third place is skipped. Dense_rank also assigns a rank but does not skip ranks when there are duplicates. It ensures consecutive ranking. If two people tie for second place, the next person gets third place because no ranks are skipped. Row_number assigns a unique number to each row without considering duplicates. Even if values repeat, each row gets a distinct number. What is the difference between group by and partition by? Group by and partition by are both used to organize data, but they work differently. Group by is used to aggregate data by grouping rows with the same values in one or more columns. It reduces multiple rows into a single row per group and is commonly used with aggregate functions like sum, count, average, etc. Use group by when you want one summary row per group. Partition by does not reduce rows, but divides the dataset into partitions while keeping all rows. It is used with window functions like rank, dense_rank, row_number, etc. to perform calculations within each partition. Use partition by when you want individual row details along with aggregated values. So, that's all for today. These were some of the most important SQL interview questions that will help you prepare confidently for any SQL interview. But remember, just memorizing answers isn't enough. Understanding the concepts and practicing them is the key. If you found this video helpful, don't forget to hit the like button. And if you want more practical tutorials on SQL, Power BI, and analytics, make sure to subscribe to Sarah's Analytics Arena. If you have any challenges in your SQL interview preparation or want me to cover a specific topic, drop your suggestions in the comments, and I'll be happy to help. See you in the next video with a new topic and fresh energy. Until then, keep learning and keep growing. Happy learning!